Welcome back, mathematicians. Today we're going to be going over writing algebraic expressions. As part of the review for this entry, I wanted you to copy down these keywords along with the corresponding operation. It's going to make our work easier with the following example problems as you learn how to demonstrate this skill. So we're going to be doing a lot of circling of key terms and using context clues, just like in your language arts class, to hopefully break down these more complex word problems with the key terms we find here to come up with an expression in algebra that we can write. So hopefully you've written that down on the left side. I didn't print it out for you because I want to save paper. If you want to print it out though, you can if you're at home. The link is on the website. This, though, you will find as the handout, it's shrunken to 85%. So what you can do is cut just along where this line meets here and then up, and it'll fold nice and evenly across this line. And then what we're going to do is we're going to kind of fold it together, and these will be flaps of certain problems that we're going to be doing. Now that you have this cut out and you fold across that solid line here, you can fold it, creates kind of a pamphlet. And what we're going to do is we're going to cut just along this solid line so that this will fold open to reveal the writing on the inside just for that specific problem. And to do that, we're just going to take our scissors and cut, not the whole piece of paper, right? Just the top flap all the way to the bend. And now you'll see that we have this example where we can write on both sides, gives us a little more room. And we'll do the same for the next couple of questions. All right, so these are actually a lot easier to write in if they are not taped into your book already. So what you want to do is just have that list of key terms by your side, and then just have this fold out on your table so you don't have to write in it. What happens is that when we open this up, if we have to write on this side, the crease of the book tends to get in the way. Or if you're using a spiral bound notebook, the spiral gets in the way and you can't write. So it's easier to have a nice flat surface. And for example 1, it's broken down into 3 different problems. So one of those problems says 2/3 of x. So we're writing an expression for 2/3 of x. Number 2 is 8 less than 4 times y. And the last one is 6 more than 1/4 of q. And what I want you to do, or us to do together, is to circle in different colors the different keywords that we see, and we're going to correspond them with what kind of operation it is. So we're going to do that right on the front here. So the first one says 2/3 of x. So 2/3 is a number, x is a variable that represents a number. So there's really only one word in there, which is of. And where do you see of in your list of key terms? You should have found it in multiplication. So of, I'm going to circle it in blue. That means I'm multiplying. So to write that as an expression for number 1, the answer would be 2/3 of, I'm just going to put a dot here, x. And you could also just write that as 2/3 x. I don't like that x. Sometimes my tail on the x gets a little too wacky. Okay, and we're going to do that for number 1, number 2, and number 3. So 8 less than 4 times y. For this one, we have 8 and 4. Those are both numbers. Y is a variable. So our keywords are less than and times. So times is kind of an easy one to see. See times, usually we say it's multiplication. Often because that's just how we speak. We say 2 times 4 and you say 8. Because when I say times, you're multiplying in your head. So that one's easy. That one it's kind of been burned into your memory for a while. So we're going to circle that one. Times, we'll circle that in blue. Okay, and then we've got 8 less than 4. So less than, if you look at your table, you'll find there are two different places it says less. In the subtraction, it says minus and it says less, right? Those both mean subtraction. Less than or fewer than both as also mean subtraction. So I'm going to circle that as well. Now, the key component here is that because it says past tense, right, like it's in the past, we're going to be subtracting at the end. Okay, because it's less than whatever comes next. That means this number here is past this phrase here. So when we write down number 2, even though it starts with 8 less than, okay, I know that at the very end I'm going to be subtracting 8. Okay, and it's 8 less than 4 times y. So right here I'm going to do 4 times y. You notice I didn't use any colors there because right here, when they're next to each other, it represents multiplication. So what you could do is you could put in parentheses 2. It's another way to show multiplication. And then less than, which is subtraction. If you want to, we can show it in red as well. So this is 8 less than 4 times y. Our third example says 6 more than 1/4 of q. And if you've looked at your table, the word of, I'm just going to underline it here, means multiply. And more than means add. Okay, and again, because this is past tense, we're going to add at the end. One way to think of it is, if I say that I have $6 more than you, and I want you to guess how many more dollars, or how many dollars I have, you need to know how much money you have first, right? So there's information missing. So when you see more than, 6 more than, you have to know this first to actually get a final answer, because it's 6 more than that. So you're going to have to do this first, and that's why we write that first when we write down our expression. So we'll open that up, and for number 3, it is 6 more than, so we're adding 6 at the end. And then the fraction was 1/4 of q. So it would be 1/4 q. So 1/4 q plus 6. And that's example 1. All right, our next example says Andrew has M coins, Catherine has 1/2 R coins. How many more coins does Andrew have than Catherine? So there's a lot going on in this problem. It's interesting when we look at the key words here in the table. More than typically means addition, and that would be true if we were trying to find out how much Catherine has. But what it's really asking is how many more coins does Andrew have than Catherine, not how many they have altogether, right? Altogether would mean we're combining, we're adding them. But if you're trying to find out how many more, you're really finding the difference, right? The difference of. So what can be confusing in these word problems is that sometimes a word can actually go from a keyword to a different keyword depending on how it's phrased. So you really have to look out for that. And I think this question is a great example of it. So Andrew has M coins. Catherine has 1/2 R coins. How many more coins does Andrew have than Catherine? So we're going to be doing the difference of that. So we're going to be taking the difference of M and 1/2 R. And to do that, we just say, well, if Andrew has M coins, Catherine has 1/2 R coins, and we're finding the difference, it's M minus 1/2 R. Typically, the one that has more goes first. Since Andrew has more coins, Andrew's term goes first, which was M. All right, for this next one, a fruit punch makes 7 quarts when made with R quarts of orange juice. This time it is being made with 30% less orange juice. Write an expression for the number of quarts of fruit punch made this time. So actually 2 different ways to think about this. It says that a fruit punch makes 7 quarts when made with R quarts of orange juice. So when you're making fruit punch, you often have like a combination of different flavors. And in this case, they're using R quarts of orange juice, but it makes 7 quarts all together. So it could be like 20, no, not 20, it could be like 3 quarts of orange juice and 4 quarts of apple juice, and that's their fruit punch. And it's not a very well blended fruit punch, but it is a 7 quarts fruit punch. Okay, so we want to make an expression that shows that this time, this fruit punch, while it did make 7 quarts, it was made with 30% less orange juice than usual. So when we're looking for keywords here, I right away see the word less. So less usually means I'm subtracting. So 30% less. Okay. The question is 30% less of what? And that's kind of where the key component is right here. It doesn't really go with it, but it's of orange juice. So we're going to be multiplying, right, the orange juice, which is R, by 30%, and we're going to be taking that away. So as we open up this section here, we've got 7 quarts of fruit punch to start with. And what we're doing, right, is we're taking away 30% of the normal amount of orange juice. So we are subtracting 30% R, because R is the variable for orange juice. And to show 30% as a decimal, we would say it's 0.3 R. Okay, so that would be my expression. Now, some people like to jump right away and say, okay, well, if it's 7 quarts and then you're taking away 30% of that, it's 100% minus 30%, so it's 70% R. But that's not the case in this word problem, because the fruit punch is not the same as orange juice. Those are 2 different things, right? Orange juice is just part of what makes the fruit punch. And now this next one, it says James paid X dollars plus 3% sales tax for a pen. Write an expression for the amount of money he paid for the pen. So whenever you see 30% or 3%, in whichever case, it's usually going to end up being multiplication. In this case, they give you an extra keyword, the word of. But always here, 3% sales tax for a pen is going to be that you're multiplying the amount of money by that sales tax. Okay, so that's going to be multiplication. I'm going to underline that in red. Okay. And then it says James paid X amount of dollars plus 3% sales tax. That plus means you're adding. And we've got some variables that he used as well. So we're writing an expression for that. And if we open this up, when James buys his pen, he pays X dollars, right? Just the variable X. But we're adding the 3% sales tax. So that's plus 3% as a decimal, which is 0.03 of whatever price that was. So that's X again. And we can combine those like terms to get 1.03x. Okay, so you're paying 100% plus 3 more percent of the price because of the tax. Now, if it was a discount, we would take that away. It wouldn't be plus. If it says discount, usually that means subtracting. But what's important here is that you're not just taking away 0.3, okay, or 0.03. What you're doing is you're taking away 0.03 times the amount of money that James paid, okay, or the full price of the pen, which was 3%. Okay, so that's really the important distinction here, is you see that. Now this next one's kind of extra difficult. It says Nancy had N baseball cards that she wanted to give away. So we don't know how many she has, but we know that amount is represented by the variable N. She gave 12 cards to her brother and then divided the rest equally amongst 4 friends. Okay, so Nancy has 4 friends and her brother. She gives 12 to her brother and then divides the rest equally amongst the 4 friends. Write an expression to show how many cards each friend received. Okay, so it's important to note that right now we start with 10 because she has 10 baseball cards. So let's start with N, just the variable N. And let's see what happens to that variable over time. Okay, she gave 12 cards to her brother, right? So when you give something, that is subtraction. And so if that isn't part of your subtraction keywords, you can write it in there. When you give away or take away, okay, those are both kind of subtraction words. So she gave away. So gave means to subtract. She gave 12 to her brother. So we're taking the number that she has and we're subtracting 12 because she has 12 less than that now. Okay. And then another keyword that pops up pretty quickly is divided. So divided means you're going to be dividing. And that should be part of your keywords key bank too, or word bank. Divided the rest equally amongst 4 friends. Okay, so we're taking this amount, N minus 12, okay, and we're dividing the whole thing, so I have to put it in grouping symbols, dividing the whole thing by 4, okay, and that's the amount that each friend would receive. Another way to write that is 1/4 times N minus 12. You can see it written both ways. The more you dive into algebra, the more you're going to see it with the fraction on the outside, just because, like before with expanding and factoring, we were able to take out a common factor. Here you'd be able to take out a 4, so it'd be like 1/4 N minus 12. That's it for the example problems. So now you can tape this to your book. Now you don't want to tape down like a whole piece of tape here, so it's going to be hard to kind of open the whole thing. So what you're going to do is take your book, open up these folds, and just tape down this part. Okay, and then these will fold back into place. Then I'm going to give you some problems to do on your own, which is just writing up some expressions as discounts and tax and sales and whatnot. And then you can move on to the practice problems in the textbook after you show your teacher. So on the left side of your book, I want you to do these 3 problems. You're writing an algebraic expression for each scenario. Number 1, Mrs. Clay bought X dollars of ice cream with a 15% discount. Number 2, Mrs. Lawler spent X dollars on a pair of boots plus a 6% tax. And number 3, Mrs. Ray has M friends. Miss O'Day has 1/2 Y friends. How many more friends does Miss Ray have? And when you're done with those 3, show your teacher, and then you can move on to the textbook practice.